Okay, this is number 7 on 4.17. Thought I'd go over it. It's abbreviated a little bit. Robert sold 6 more magazine subscriptions the second week than the first week. He sold twice as many the third week as the first. If he sold 94 in all, how many did he sell the second week? Okay, so let's kind of go looking. As we read through this, we know we're going to eventually back up and start at the beginning, but let's go looking for some key words here. And if you remember, some of the key words that we talked about were than and as, and let's see how many of them we have. There's a than, as. Okay, so we see we've got some thans and ases. Now, why am I looking for those? If you remember, than usually tells us whatever, than or as, whatever comes right after it usually tells us a good thing to make our variable choice in a word problem. Remember, I want to list all my variables and describe how I'm going to label everything. If you look, what comes after than? First week. What about over here? First. They're talking about the number of magazines sold the first week. I abbreviated some of this down just so I wouldn't have to type so much up on the screen. So let's let X equal the number of magazine subscriptions, I'll just put subs, sold first week. Okay? Now, if you look at what's going on there, he sold some magazines the first week, he sold these subscriptions the first week, and then he sold some more the second week, and then he sold some more the third week, and if you add them all up together, he sold 94 in all. I want to see something like this on your paper, too. You could write it all out in words and then go to the next line and start putting your numbers in. You don't have to do it like this, but choose one of the two ways. Either write your equation out in words or do something like this. Well, okay, so I know that we got to tell how many sold the first week. We need the number. I'm just going to put a little dot here to show that number he sold second week. And we need to describe the number he sold, I'll put third week, okay? Now, let's go at the beginning and let's read and see what's going on. We've got the big idea. He's selling a bunch of stuff and he sold 94 in all. You can imagine you were selling something for 3 weeks and you want to see how many you sold in all. You would just add up each week what you sold. So let's go back now and look. Robert sold 6 more magazine subscriptions the second week, so 6 more the second week than the first week. So if you take what he sold the first week and you add 6 to it, that's what he sold the second week. More than means you add 6 to something, and what we're adding 6 to here for the second week is the first week. So we can describe the second week as X plus 6. Now, if you go back and read, that's actually what they want to know here is how many did he sell the second week. So this is actually this thing that we're going to be actually answering the question at the end. I'll just kind of circle this. Maybe that'll help me remember that I've got to go figure that out at the very end. Okay, so how many did he sell the third week? I'll just change colors here. Here we go. He sold twice as many the third week as the first. So if you take what he sold the first week, he sold twice as many. Do you remember twice means multiply something by 2? So what am I going to multiply by 2? Twice as many the third week as the first. As is another word that usually means multiply. Okay, so what did we call the first week? We called it X. So he sold twice X, 2X. Okay, we've described the first week, second week, and third week sales now with variables. So now we can go put them in our equation. All right, the first week was X, the second week was X plus 6, and the third week was 2X. Okay? Now remember, a lazy math guy doesn't write these ones out front, but I'm going to go ahead and try it on them in, even though it didn't work out real well. Because now I'm going to be combining like terms. I'm going to solve this, but if you remember, before I solve it, I have to simplify both sides. So let's look at the left-hand side, because the right-hand side doesn't need any simplifying. It's just 94, isn't it? All right. I've got an 1X and another 1X. That makes 2X. And 2X and 2 more X's make 4X's. Remember, when we combine like terms, we write the like term down. So we'd write X down. And then we add the numbers out front. 1 plus 1 is 2, plus 2 more makes 4. All right, but I've also got a plus 6 that I need to write down. Once I get it to this point, all my variables are on one side. And I want to get the variable by itself. So that's when I start thinking I'm going to do PEMDAS backwards. In other words, I'm going to add or subtract first, and then I'll divide last, okay? So if I want to get anything away from x by adding or subtracting, I could subtract 6. 6 minus 6 is 0. That made it disappear on this side. It added up to 0, and 4x plus 0 would just leave 4x, right? Well, 94 minus 6 is 88. X still isn't by itself. It's multiplied by 4. The opposite of multiplying by 4 would be dividing by 4, and if I do it to one side, I got to do it to the other. Now, when that cancels out, I end up with x equal 88 divided by 4 is 22. Now, a lot of people, when they did this, circled the answer 22, but that's not right. They ask you, how many did you sell the second week? How did we describe the second week? Oh, remember I circled it over here. It was x plus 6. So I have to plug in x is 22. I used all that equation to find x, but that wasn't my answer. They could have asked me for how many sold each week, and I would have had to give 3 answers. So just be careful to answer the question they ask. 22 plus 6 is 28. So remember, we want our answer in a sentence. He sold 28 the second week. I mean, you can do what I'm doing right here. I'm keeping it short and sweet, aren't I? I didn't even put he sold 28 magazine subscriptions the second week. I didn't even spell out second, but that's okay. We're just trying to get something down there to express the answer in a way that communicates clearly that, what they asked. Okay, number 11 it's a little bit different than some of the other ones in this section in that there's 2 sentences and we get 2 different things from each sentence. Okay, so let's look at this. Let's look for keywords. Charlie is a fourth as old as his father, and the sum of their ages is 45. Okay, so some keywords that I see. As. Oops, let me get it where it'll let me do that. As. As, usually the thing that comes after as or then, remember, makes good variables. So what comes after both of these is father. So probably what we're going to do here, and I haven't even read the whole problem to think much about the relationship of things, but I just know because that as is there, the father's age is probably going to be X. Now when you get done, you need to tell me, you don't want to just tell me X equal. That's not what you do in a word problem. You have to say the father is blank years old and Charlie is, and we'll just put blank. Okay, so this is where I'm going to put my answer in a minute. Just making a point of it, because look what they ask you. They ask you how old is each, and we need to tell who's who. We don't just put 2 numbers down. You got to be clearer than that. All right, so going back now, let's see if we can describe Charlie. We got his father's age, so we know somehow we're going to have to describe Charlie. So Charlie's age here. Charlie is his fourth as old as his father. Now remember, the word as can also usually means multiplication. So if he's his fourth as old as his father, and we called his father X, a fourth as X would mean a fourth times X, so it will be 1/4 X. Okay. The first sentence told me how to describe Charlie and his father's age. Now let's go to the second sentence. The sum. Sum means we're going to add 2 things and come up. Sum means we're going to add 2 things. And what did they tell us they add to? The sum of their ages is 45. Is means equal, so 45 is what they equal to. And if we're adding their ages, if we're summing their ages, then Dad plus Charlie is 45. Well, we know what those amounts are because we already labeled our variables up here. Always label your variables, okay? So Dad is X, Charlie is a fourth X. Now I want you to, there's a couple ways to do this. We could clear the fractions, but I'm going to do what most of you thought to do here. If you think about it, you've got 2 like terms. You've got 2 X terms. So we'll write our X down, and we're going to add the numbers out front. What is 1 plus a fourth? It's 1 1/4. Now remember how I told you fractions, mixed number fractions are not very helpful in math. We always want to write them as improper fractions because we can't really solve it like that. So we're going to have to say 4 times 1 is 4 plus 1 is 5/4x. Okay? Now, do you remember how to get rid of a fraction when it's multiplied times the variable? You multiply by the reciprocal. Okay, so we're going to multiply both sides by the reciprocal. That causes everything to cancel out. We get x equal, let's reduce on the right-hand side. 5 goes into 5 once. 5 goes into 45 9 times. 9 times 4 is 36. X equals 36. Do not circle that and tell me that's your answer. What was X? Oh, that was the father's age. So you know what? The father is 36 years old. How old is Charlie? Well, Charlie is a fourth times X. So that's a fourth times 36. 4 goes into 4 once. 4 goes into 36 9 times. So that's 9. Charlie is 9. And there you're done.